Hey guys, this is the day 6 assignment for proportional reasoning. I'm just gonna work with, I'm just gonna work a couple of these from now on, and then have you guys do maybe one or two at home, and then the rest we can leave blank just to make our lives a little easier. I know you guys have other classes and stuff, so I don't want to pile it on. Okay, but today's an exception. I'll do 2, 3, and 9 because some of you guys struggle with the multiplication of including a negative number. So during the test. So I'll work on that. Before we begin though, I want to make a slight correction. Last week I said if there is a remainder, we cannot easily use scale factoring, so we'll move over to the butterfly method or cross multiply. That was incorrect. And then I made a correction, which was if the number is too big, we cannot easily use scale factoring, so move on to cross multiply. Also incorrect. Guys, this is just a matter of preference. If you guys want to use scale factoring, you can. Remainder or not, you can still multiply by a number including a decimal, and you'll still get a valid value. It's really just a matter of preference. I tend to start with scale factoring. It's just easier to look at something really quick and go, oh, how many times is this going to this? And then do the same thing to the top. But if for some reason you run into a hiccup there or anything, just move over to cross multiplication. But it's really just a matter of preference, whatever you guys want to use. So that out of the way. Let's say, right. Oh, and again, so the answers are all here, obviously. I'm just going to show you how we get there. So let's start with number 2. Scale. Set up a proportion and solve using the preferred method. See, preferred. Either scale factoring or cross multiply. We're going to call this the butterfly method from now on because a lot of you seem to like that. Right, so the butterfly method is the new name. So let's get rid of all the unnecessary information. Carol spends 17 hours in a 2-week period practicing her culinary skills. If she continues at this rate, how many hours will she practice in 8 weeks? Let's see. I see 17 hours, forget the name, per 2 weeks. And the question is, if she continues at this rate, so it's going to be an equality, how many hours will she practice in 8 weeks? How many hours per 8 weeks? So use scale factoring or cross or butterfly. Right. Okay, so we'll say also I want to just add that our unit placement does not matter. So arbitrarily, or just because I want to, I'm going to put hours on the top and weeks on the bottom. And so long as I stay consistent, I keep all the weeks on the bottom and the numbers for the hours on the top, then I shouldn't have a problem. Okay, so we have 17 per 2 weeks. And at this rate, so equals, because it says at this rate, right? How many hours per, excuse me, 8 weeks. Okay. So now we'll just say how many times does 2 go into 8? Like I said, I tend to start with scale factoring. So I know 2 goes into 8 about 4 times, not about, exactly 4 times. So how many times is 17? Well, do we multiply 17 by to get this value x? Well, we multiply it by 4. Because I have this written up here, I'm just gonna do that in my head. So 17 times 4 is going to be 68. So that means x is equal to 68. So our answer is 68 hours. Yeah. And number 3, a rainstorm produced a rainfall of 4 inches per hour. At this rate, how many hours would it take to get a rainfall amount of 1 foot? Right here. Okay. So I see another thing I noticed during the test, some of you guys were like referencing an old question when asking me another question about, so you'd be like on number 3, right? And you'd be looking at work from number 2 and asking me about it. But it'd help if you guys made a line after you finished the problem. So that way, you know, I can't go above this line when I'm referencing anything, you know? So you just don't get confused and put the wrong value somewhere. So number 3, I see 4 inches per hour. So that's 1 hour. Per 1 hour, right? How many hours per what? 1 foot. And guys, we haven't done too much in regards to unit conversions, but I want you to do your best to memorize this one simple fact, that 1 foot is equal to 12 inches. That'll be our key. 1 foot is equal to 12 inches. So I can easily just circle this, put a little arrow through it, and then convert it to 12 inches. Right? So it's the exact same thing. How many hours per 1 foot, or how many hours per 12 inches? Only reason I did that, guys, is because they give us inches up here. So inches per 1 hour. I can compare hours to this hour, but I can't compare feet to inches without converting this back to inches. Okay. So again, like, I'm going to use scale factoring or butterfly. And let's just begin. I'm gonna put my inches on top, and I'm going to put my hours on the bottom because I want to. It doesn't matter where I put these. Unless they're asking for unit rate, it does not matter where you put your units, okay? Unit rate, always put the bigger number on top, right? Only for unit rates. So like right here, I can say not unit rate. So placement doesn't not matter. There you go. So it says, what do I see on number 3? 4 inches per 1 hour at this rate. Oh, I forgot to write the question down. At this rate, how many hours would it take to get a rain for 1 foot? Oh yeah, I did write the question, okay. So I see 4 inches per 1 hour at this rate, so it's inequality. Here you go. I'll just say at this rate, how many hours, we don't know it, per 1 foot or 12 inches. Because see how I don't have a feet of that unit in here, so that's why I converted it. Okay, so this is really easy to solve using scale factoring, but just for practice, I'm going to use the butterfly method, which is when you take the diagonals and multiply them. Multiply everything diagonally. So that turns into what? 4 times x equals, what is 12 times 1? 12. Now the goal is always to get the x by itself. So let's divide by 4. And we're dividing because you are multiplying 4 by x. This is just like any other number, right? If you see anything like this, it means it's being multiplied. And what's the opposite of multiplication? Division. So if I divide by 4, I can get the x by itself. What I do to one side, I must also do to the other. So I'm going to divide this by 4. That cancels the 4 out. 12 divided by 4 is 3. So now we know that x, sorry, I like to just put my answer up here. Down here, I'll just say x equals 3. That's our answer. 3 hours. Boom. Okay, let's go to number 9. Negative 12 times 44. Okay. So for this one, just know that, again, this don't let this format scare you. This is the same as negative 12 times 44 is the same as negative 12 times 44. You know, remember, I kind of want you guys to veer away from using this x as for your multiplication. The dot is probably better, or the parentheses, but these are all the same thing. So let's say, what is 44 times 12? And let's move on to the next page to do that. Right, so number 9. So we'll just say 44 times negative 12. For now, I want you guys to just ignore the negative, and then we're gonna do something with it at the end, right? Here's your little key too. Neg times neg equals pos, like positive. Another thing I want you to know is that negative times a positive equals a negative. And obviously a positive times a positive equals a positive. This is what you're used to. Use this as your key. And maybe during the next test, I'll write something on the board akin to this. But yeah, so what we're dealing with now is a positive times a negative. So a positive times a negative is equal to a negative. So let's just ignore these two for now. The negative sign and this key, we'll ignore it. And let's just do what we know. What's 2 times 4, 8. 2 times 4 is 8. And then we have our placeholder down here. 1 times 4 is 4. 1 times 4 is 4. And then we just do our addition, right? So 8, 12, 5. Okay. Now that we did that, let's go back and consider our negative sign. What is a negative times a positive? We'll look over here. A negative times a positive is a negative. So we'll put a negative in front of there. Yeah? This is our answer. 528. Negative 528. All right, thanks for watching, guys.